Good morning. Welcome to the live class of MAPC 005. If you have joined the live, please type your name, institutional center code, and enrollment number so that your attendance can be given and I can start the class. Yes, Shrabani, good morning. Please write your name, center code, and enrollment number together. Please write your center code, name, and enrollment number together. Good morning, Ishika. Good morning, Shomalika. Please write your details in chat box. Good morning, Tenzin. Good morning, Drisha, Jilam, and Priyanka. Write your details. Okay, if you have joined the live, let us begin. Yesterday, we finished two chapters, two units of block 3. Another two units are left in block 3. Let us begin with that. Unit 3 in block 3, it includes quasi-experimental design. Now, what is quasi-experimental design? The word quasi means as if or to a degree. Thus, quasi experimental design is one that resembles an experiment but lacks at least one of its defining characteristics. It is also said semi experimental design. That means it appears like experimental design, like single factor or factorial design within or between group design. It appears like that, but in quasi experimental design, certain features of true experimental designs are missing. Certain definitions are given here. I am just referring to the one said by Bruta. He said, all such experimental situations in which the experimenter doesn't have full control over the assignment of experimental units randomly to the treatment conditions or the treatment cannot be manipulated are called quasi experimental design. Uh, Now, from this definition, it is quite clear that you cannot apply the technique of randomization in a proper way uh, while you are assigning experimental units to the treatment condition. You must have remembered what is treatment. When you assign certain experimental units to a factor, it becomes treatment. For a true experimental design, where in a laboratory situation where the experimenter has full control over the factors, over the experimental units or participants, he or she can manipulate it at their convenience. Uh, However, in case of quasi experimental design, the experimenter can neither assign the subjects randomly, nor he or she can assign the treatments randomly, or the researcher cannot introduce independent variable or apply independent variable at their convenience. Eke Singh in 1998 he said that a quasi-experimental design is one that applies an experimental interpretation to results that do not meet all the requirement of a true experiment. Actually, in your project or in the dissertation, in different types of doctoral thesis, it is not possible to uh, conduct a true laboratory experiment in psychology. I am talking about psychology. So, in most of the cases, we use quasi experimental design in a field situation, that means in a real life situation. There are many other definitions given. I am not going to that. Let us come to next difference between quasi experimental design and true experimental design. What happens? What are the differences? Um, in true experimental situation, Experimental has complete control over the experiment. But in quasi-experimental situation, the experimenter does not have control over the assignment of subject to condition. In true experimental design, we manipulate variables. We means researcher. Researcher has the capacity to control to manipulate variables, but in quasi-experimental design, manipulation of variable is not possible. Here, what researchers do, they observe categories of subjects. For example, if we want to study the effect of gender, then we cannot manipulate gender. We simply label groups according to what we think is the important difference between them. Therefore, you may say, in a way, not always, ex post facto researchers use quasi experimental design. There is a relation between these two. Said here, in quasi experimental design, we present some independent variables or two to the researcher presents some independent variables to two pre-existing groups. They may do so. That means in ex post facto, this is the difference between again ex post facto research and quasi-experimental design. I have said that in some cases, ex post facto researchers use quasi-experimental design, but in other cases, like in this mentioned in third point, here what they are doing, they are introducing, the researchers introducing variables to pre-existing groups. That is the not feature, that is not the feature of ex post facto design. In ex post facto design, there is no scope to introduce any independent variable. That already has been taken place. We are just observing its effect. But in case of quasi-experimental design, there can be pre-existing groups and we can present some independent variables to pre-existing groups. We may not know whether the difference in behavior was caused by difference between the groups or by the independent variable. That is a limitation of quasi-experimental design, that there the subjects cannot be selected randomly from the population. uh, Maybe the groups are pre-existing, there we have to apply the independent variable, and that's why we do not have control over the subject selection. So naturally we may not know that whether the difference is due to the difference between groups or due to the difference of independent variable or application of independent variable. A quasi experiment leaves open the possibility that other differences exist between the experimental and control conditions and thus permit other potential differences. That means there we cannot establish the cause and effect relationship properly. Now let us come to the types of quasi-experimental design. There are 10 types of quasi-experimental designs mentioned in this study material. Let us discuss them one by one. The first one is non-equivalent group post-test only design. That means like we may take two groups of subjects and we may administer some independent variable to them. For example, one group of students might receive reading instruction using a whole language program, while the other group of students receive a phonetics based program. That means two types of independent variables are administered to two different groups. After that, their reading comprehension is compared by administering a reading comprehension test. But what is the fallacy? What is the limitation there? That two groups, they are might not be necessarily the same before any instruction takes place. That means there is no pre-test condition. In true experimental design, we may take one group, we may take two groups, we may take multiple groups, but there are always a baseline measurement. A baseline measurement means a measurement of dependent variable before applying independent variable. So there can be a proper comparison done. But in case of quasi-experimental design, there is no pre-test condition. So if we compare the effect of two different independent variables on two different groups, how it will be possible to say that whether the difference is due to the sample or due to the application of two different independent variables, because we have not taken any measure before the application of independent variable. That is why this type of non-equivalent group post-test only design, they have limited application. For instance, if it is found that the students in the phonetics group perform better, suppose it is found, there is no way of determining if they are better prepared, if they are better readers, or if there are other factors that influence their better performance. Cannot be said. Next comes non-equivalent control group design. Here in this design, a control group and an experimental group is compared. However, the groups are chosen and assigned out of convenience rather than through randomization. Here we have the scope to use a control group and an experimental group. Uh, Control group means there is that the pre-test condition. There is no application of independent variable. I have already discussed it. So there may be a control group and an experimental group. But first of all, the groups are not randomized. The groups are not even matched. They are taken just by convenience. The kind of things that have come, the kind of the participants that have come in my way, I have taken them. So that is a purposive, that may be a purposive sampling, that may be what to say, non-probability sampling, a biased sampling. There are so many kinds of non-probability sampling, like snowball sampling, accidental sampling, incidental sampling. What happens in those cases? We just take participants according to my criteria, whoever has come uh, to my realm of research, whom I have met, whom I have uh, scope to communicate with, I have taken them. No proper randomization has done. The experimenter could not, for example, we are interested to study the effect of special training programs on grade point average of 10th grade students. The experimenter could not draw a random sample because they are taking 10th grade students only of a particular school. There is no scope of randomization, as the school will not permit the experimenter to regroup the classes. There can be this type of administrative limitation. Therefore, researchers selected two sections of 10th grade from the same school. Because the subjects were not randomly allocated to the two groups, it cannot be said that the groups are equivalent. Before the experimental manipulation was performed, there was no scope of matching, there was no scope of randomization. only two sections are taken for the administration or non-administration of independent variable. That the special training programs here, the independent variable is special training program, and the grade point average is dependent variable. You need to identify independent and dependent variables first in a problem before proceeding to the later steps. So just go through all the examples clearly and practice it. Practice to how to identify independent and dependent variables. Um, so here the groups are not equivalent before the experimental manipulation was performed. And if we compare the grade point average, then how it is possible to identify the factors that may influence the grade average grade point. In the study material, you will find diagrams for different designs. It is not possible here to show you those designs separately. Just look at your study material and you will find it. Again, there is the separate pre-test, post-test sample design. There, the basic idea in this design is that the people we use for the pre-test are not the same as the people we use for post-test. Neither they are what to say, equivalent, not they are matched, not they are randomly placed, but simply two or three or four groups of subjects may be taken. The example given here, it includes four groups, but two of these, one groups come from a single non-equivalent group, other two also come from other single non-equivalent group, like this. For example, let us say uh, the researcher has two organizations for study, and the researcher thinks uh, that these two organizations are more or less similar. So he wants to implement his study in one organization and use other as a control. That means in one organization he is going to administer his independent variable, but in other he is not introducing it, but taking that organization into comparison. You want to implement your study in one organization and use other as a control. You design a program to improve customer satisfaction. Because customers routinely cycle through your organization, you cannot measure the same customer pre-post because they are coming and going. You cannot test them uh, in a systematic way. Instead, you measure customer satisfaction in each organization one point in time, then implement your program, and then once again measure customer satisfaction in the organization at another point in time after the program. Here, the customers will be different within each organization for the pre-test and post-test. You cannot control the customers who are coming before the implementation of program and after the implementation of program. The groups are totally different, but you are comparing them. Here, we cannot match the individual participant responses from pre to post. We can only look at the change in average customer satisfaction, that before implementing the program what was the average level of customer satisfaction, and after implementing the program what is the average level of customer satisfaction. If it is improved, then the program is effective. If it is not improved, then the program is not effective. That's how the conclusion can be drawn from this type of design. So, as we are proceeding, you must see that there are certain loopholes, there are certain limitations in those design. But still we are using them because in real life situation it is not always possible to control all the factors. Then there is the double pretest design. This is a very strong quasi-experimental design with respect to internal validity. Because in pretest non-equivalent group design, the non-equivalent groups may be different in some way before the program is given, and we may incorrectly attribute post-test differences to the program that we have discussed. Although the pretest helps to assess the degree of pre-program similarity, it doesn't tell us if groups are changing at similar rates prior to the program. We cannot control that in other types of non-equivalent group design. But in double pretest design, what extra things are included? Two measures prior to the program. The groups or the group are measured twice before implementing the independent variable. Consequently, if the program and comparison group are maturing at different rates, we can detect this as a change from pretest 1 to pretest 2. Actually, we apply these two pretests at two different points of time, not simultaneously. Why? In order to observe that whether without implementing the independent variable there is any change in the sample group. If in 2 points of time there is a change of dependent variable in these two sample groups, then we can take it as the rate of change in the sample group, and we can then better judge the effect of independent variable in the post test condition. Therefore, this design explicitly controls for selection maturation threats. Actually, with time, everything matures. A child matures definitely. Even an adult matures with different types of experiences and exposures. That is why double pretest design can give us a check on that. Next, the fifth one is the switching replication design. The switching replications quasi-experimental design is also very strong with respect to internal validity. This internal validity means the finding is purposeful for at least that particular sample group if cannot be generalized with the external situation. That is internal validity. The next one is the switching replications design. What is that? It allows for two independent implementations of the program. Program means here the independent variable. It may enhance external validity, that means the capacity for generalization or generalizability. That design has two groups and three phases of measurement. In the first phase of the design, both groups are pre-tested. That means the dependent variable measures are taken without applying independent variable. Then one is given the program or the independent variable, then both are post tested. So this is called switching replication design. In the second phase, what happens? The original comparison group is given the program, while the original program group serves as the control. Means uh, the one who is post tested is they can serve as a control, and the original comparison group, the group with whom I am comparing uh, the effect of the program or the independent variable, it is given the there the independent variable has implied or applied, sorry, the implementation of the program has taken place. This design is identical in structure to its randomized experimental version. You may remember the single factor design in between groups in unit 2. But what it lacks? It lacks the random assignment to group. But it is certainly superior to the simple pretest non-equivalent groups design. Since we have administered uh, pretest to both groups, then we administer independent variable to one group and not to other, then we again take post tests and compare. There is a comparison between two groups in pretest condition ones and post test condition ones, but the limitation is that there is no random assignment of sample. Now come to the sixth quasi-experimental design. It is mixed factorial design with one non-manipulated variable. Um, Anything you want to ask in this point, at this point? Okay, I guess there is no more questions here. Okay, let us get back to the rest of the designs. This mixed factorial design with one non-manipulated variable, it was explained by an experiment by Edmond Keogh and Garkevich in 2001. Example comes first here. What they hypothesized, that caffeine intake might influence the perception of pain and that the effect may be different in men and women. So, like factorial design, there is two independent variable. One is caffeine intake, another is gender. And the dependent variable is perception of pain. So 25 men and women took part in two sessions separated by a week. In one session, the participants drank a cup of coffee that contained caffeine, and in the other session, they drank decaffeinated coffee. In both the sessions, the participants put their non dominant hand in ice water bath. We know excessive cold may produce pain sensation, and to indicate the point of just noticeable pain. Uh, this is the design. This is a type of mixed factorial design, and with one non-manipulated variables. What is the non-manipulated variable here? The gender. We are manipulating the caffeine intake. We have given them once caffeinated coffee and once decaffeinated coffee, but we cannot manipulate their gender. So there is only one non-manipulated variable, and it is a mixed factorial design. Now comes the seventh design, interrupted time series design. These are research designs that allow the same group to be compared over time by considering the trend of data before and after experimental manipulation. So it is a kind of pre-testing and post-testing, but it occurs on same group across a time period. It is called interrupted time series design. Some, because why interrupted? Sometimes there is an interruption between tests in order to assess the strength of treatment over an extended time period. We are not assessing them continuously, before giving and after giving, not like that. After the implementation of independent variable, we may give some time gap, some interruption we produce. After that, we may take the post-test measure. So it helps us to assess the strength of treatment over an extended time period. That means how far the treatment given to them is effective after a long period of time. Number 8 is multiple time series design. In this design, we have two groups. One group receives treatment and the other group does not receive the treatment, and this group acts as the control group. Simple. There are there is one group which receives treatment, and the group which does not receive treatment acts as the control group. What is the difference between pre-test and post-test design here? Design in this case, uh, it actually takes place in a complex setting with many events. No control has been imposed here, and trends that might affect the behavior in question. Behavior in question means the dependent variable. The addition of a comparison group for which the same series of measures is available but which is not exposed to the treatment, whose effects are being studied, can be useful in clarifying the relationship between the treatment and any change in the series of behavioral measures being used. There, I am doing the pre-test post-test design, but in a complex setting where there can be many other variables, and I am conducting it over an extended period of time. Next comes repeated treatment design. Repeated treatment design is one in which a treatment is withdrawn and then presented the second time. That means in the independent variable that is applied there, that is given repeatedly, not once. In other design, what we have found, that there is one condition where no independent variable is given, then there is one condition where independent variable is given, and once. But in repeated treatment design, the independent variable is applied uh, more than once. So after pretest, we may apply treatment, then we do post-test 1. Then we withdraw the treatment. Then again we apply treatment. Then again I do the pretesting. I mean, I compare the first pretest with the second post-test. That means after application of independent variable for the second time. This is called repeated treatment design. And the last one is counterbalance design. This is more scientific, I must say. Counterbalancing we have discussed yesterday. It is also called crossover design by Cochrane and Cox in 1957. The name counterbalance was given by Underwood in 1949. In this design, the experimental control is achieved by randomly applying experimental treatment. Here, each treatment appears once and only once in each column. Like I have given the example of ABC, three treatments. It can be applied as ABC, BAC, CAB, ACB, BCA, like that. It will be placed in such a way that each treatment will appear once in each column and in each row. It is used to check the effect of maturation, selection, and experimental modality, posing threats to internal validity. These are the factors that may be controlled through this counterbalanced design. Now let us come to the advantages and disadvantages of quasi-experimental design. In advantageous part, we may say that it is not possible always in social science that pre-selection and randomization groups can be done. So this quasi-experimental design can be very useful in generating results for general trends. For example, if we study the effect of maternal alcohol use when the mother is pregnant, we know that alcohol does harm embryos. We know that. A strict experimental design would include that mothers were randomly assigned to drink alcohol. But this is not possible. We cannot make a mother drink alcohol because this is highly illegal. We know this can cause harm to embryos. So we need to select the mothers, the pregnant mothers who intake alcohol and who do not intake alcohol. So this is one advantage of quasi-experimental design. Again, what happens in quasi-experimental design? It is often integrated with individual case studies. The figures and results generated often reinforce the findings in a case study and allow some sort of statistical analysis to take place. Case study, we have discussed that we are observing a case or a small number of individuals or even a large group, but together they form a case. Their quasi-experimental design can help us to get some statistical treatment which was not possible while we were doing simply the case study. In case study, there is no scope of doing statistical analysis. But if we apply some kind of quasi-experimental features to the case studies, we may use statistical treatment, at least some sort of statistical treatment, in order to establish the finding. In addition, without extensive pre-screening and randomization needing to be undertaken, what happens? They reduce the time and resources needed for experimentation. That means it is more economical than the true experimental design. Since quasi-experimental designs are used when randomization is impossible and or impractical, they are typically easier to set up than true experimental designs. It is easy to conduct. Also, this kind of designs minimizes threats to external validity as natural environments do not suffer the same problems of artificiality as compared to a well-controlled laboratory setting. In quasi-experimental design, it is easy to establish external validity. External validity means generalizability. The finding can be generalized to other situations, to other groups, which is not possible for a well-controlled laboratory group because the laboratory setup is more artificial than the natural one. And since the quasi-experimentals are natural experiments, there is some scope of generalization about the population in question. This experimentation method is efficient in longitudinal research. While we want to perform longitudinal research, this type of experimental design may help us in like this in time series design and multiple time series design. Uh, in those kind of designs can be applied to the longitudinal research. And in addition, without extensive pre-screening, it can uh, be more economical. That is the point. And what are the disadvantages? Naturally, for the advantages I have already discussed, they can also serve as disadvantages. That is lack of proper randomization. It is not very effective when we are using statistical treatment for a non-random group, since we cannot generalize we cannot make the necessary control to apply a proper statistical treatment. Some may think that the total process is meaningless. Um, well, what are the other disadvantages? A quasi experiment constructed to analyze the effects of different educational programs on two groups of children might generate results that show one program is more effective than the other. These results will not stand up to rigorous statistical scrutiny. The disadvantages mentioned in your study material more or less include these 2 points, that lack of proper randomization and lack of application of proper statistical tests and treatment. Um, and it is not possible since there is no proper randomization data. The conclusion obtained from the data, they cannot establish proper cause and effect relationship. It is not possible, and there may be threats to internal validity. These are the more or less disadvantages of quasi experimental design. The next unit, it includes unit 4. It includes two types of design. One is correlational design and one is causal comparative research design. Now, what is correlational design? Um, Correlational design is one in which the researcher collects two or more sets of data from same group of subjects so that the relationship between the two subsequent sets of data can be determined. You may ask for the example. I mean, suppose the researcher attempts to um, determine the relation between violent TV program and aggressive behavior of children, that we said in the first or second class. I mentioned that example. So we may take two sets of data from the same group of children. One about the exposure time of um, violent behavior, violent TV program, and another about the intensity of violent behavior afterwards. Both can be quantified and both can be correlated. The relationship between that means it cannot establish, it does not establish the fact that uh, violent TV program is the only cause of violent behavior. That cannot be established in a correlational design or in a correlational statistical treatment. But it can be said that where the exposure time of violent exposure and frequency, exposure time and frequency of the violent TV program is more, the intensity of violent subsequent violent behavior is also high. So there is a relationship between these two types of variables. Again, correlational research can be broadly categorized into broad divisions. Those that measure the degree of association between variables and those that are used to predict the score on one variable using knowledge about one or more variables. While the within the former, that is those that measure the degree of association between variables, we may have association between two variables and association between more than two variables. Where the association is between two variables, it is called bivariate relationship, and it may like that if the variable, the value of variable x is increasing, the value of variable y is also increasing. That is called direct relationship. And it may happen like that if the variable x, the value of x, variable x is increasing, the value of variable y is decreasing. That is called inverse relationship. That means when one is increasing, another is decreasing, and vice versa. Like, for example, let us say a researcher wants to study the relationship between academic stress and academic achievement. So, if it is found that academic stress is increasing with the higher academic achievement, then it is a direct relationship. Both the variables are increasing, both the variables are decreasing simultaneously. But if it is found that academic stress is increasing while academic achievement is decreasing, and vice versa, then it can be said that there is an inverse relationship between two variables. And what more? We indicate a direct relationship with a positive correlation sign, and we indicate a negative correlation or a negative inverse relationship with a minus sign, a plus sign and a minus sign. And when we discuss the association between more than two variables, what can be the example? So what if academic stress and academic achievement have significant correlation? And what if study habits, intelligence, and other factors were also associated with academic achievement? Then we can also measure the association between all these variables in the same group of children. And we try to predict the score of academic achievement from the knowledge about the score of academic stress, study score of study habits, and intelligence score. If we have all these scores in our hand, then we may predict and can predict the value of uh, academic achievement. So, academic achievement is termed as criterion variable here. This is a kind of regression. It is called regression, where we try to predict the value of one variable from the values of other variables, other known variables. Then the value we try to predict is known as criterion variable, and the variables that are used to make a forecast about an outcome, that means here the study habit, intelligence, and stress, all these are they together called predictor variable. So all these things are predictor variable, and academic achievement is criterion variable. This is called regression analysis. What are the advantages of correlational design? It can be used in many cases because available data makes it easy to use. Some more careful researchers use the result of correlational studies to formulate new hypotheses, which they can test later using more rigorous research design than test hypotheses about cause and effect directly. It is wise for researchers first to establish if there is at all any relationship between variables. If there is no relationship, how do we calculate no relationship? When it is near to zero. When the correlation value is near to zero, it is called no relationship. And when it is more towards plus one, we call it a direct relationship, a positive relationship. And when this is more near to uh, minus one, we call it negative relationship, inverse relationship. So the range of correlation value, it it is limited between plus one and minus one. And if the value is near to zero, we call it no correlation. So if we find that there is no correlation between certain factors used in the research, it is unnecessary to conduct further experiment on it. So it is wise first to establish the correlational I mean establish the relationship between two variables. Then it is wise to search for cause and effect relationship, that which one is the cause and which one is the effect. If there is no relation found, it is futile to determine that which one is the cause and which one is the effect. And also it is used as the foundation for other design. It usually does not involve repeated administration of a behavioral measure, thus avoiding pretest sensitization. We do not need any pretest condition in correlational design. So there is no threat for sensitization about the dependent variable in pretest condition. And next one is what? It is uses very realistic measurements of behavior, and its possible causes as well. It can be used in real life setting. Also, it avoids the problem of non-representative research context. It also permits the use of large, carefully chosen sample, thus avoiding the threat of non-representative sample of participants. We can select sample for a correlational design with caution, so that it is not uh, become a non-probability sample. Non-representative sample means it does not represent the population. Does not represent a population, it cannot be generalized for a population. This threat can be avoided in correlational research. But What are the disadvantages? We cannot determine the actual reason for association. Why these variables are associated, we cannot determine that. For example, there is a positive correlation between exposure to violent programs on television that I have mentioned repeatedly and violence on the playground. If we find the correlation rather positive and high, we may be tempted to conclude that exposure to violent television causes children to be aggressive and violent. But this conclusion is not completely warranted. We cannot infer cause and effect relationship from a correlational study. And also these kind of designs have directional problem. The causation is reversed from the expected direction. We may have thought that these two have inverse relationship, these two may have direct relationship, and we may find the a different result. So it is not wise and it is not possible to designate one of the variables as IV and one of the variables DV arbitrarily. In true experiments, there we can designate them, there we can classify them, that which one will be IV and which one will be DV. But here it is not very much possible to identify which one is IV and which one is DV. Children may watch violent television program because they behave aggressively rather than the other way around. Since I am exposed to aggression already, therefore I prefer to watch violent TV programs. So the violent behavior in playground may be IV and the violent program watched in TV may be DV. So it is very much confusing in correlational design to identify IV and DV, and hence the internal validity of the correlation design is very low. Then comes causal comparative research design. Now, what is causal comparative research design? Now, in case of, in many occasions while conducting research in psychology, it is not possible to control independent variable. Suppose the effect of gender on aggression. Here the independent variable is gender and dependent variable is aggression. For example, the study of the effect of diet, vegetarian versus non-vegetarian, on mental health. There also we cannot manipulate. We cannot forcefully feed a vegetarian person non-vegetarian food and a non-veg person vegetarian food. We cannot do that. It is unethical. In that case, what we do, we use causal comparative design rather than true experimental design. What is the basic design of a causal comparative research? Is to select a group that has the independent variable and then select another group of subjects that does not have the independent variable. That means it is already present, the control or comparison group. For example, in school, some of the 7th grade math classes use handheld calculators. We want to find the effect of calculator use on mathematics grades at the end of the year. So we select a group of students from the classes which use calculators and then select another group of the same size from the classes who do not use calculators. There I am not introducing the use of calculator anywhere. I have just taken this is kind of quasi-experimental design, but what is the difference? I am neither introducing nor manipulating any independent variable here. The independent variable, that means the use of calculator, is already present in a group and already absent in a group. I am just comparing the dependent variable, that means the maths grade between these two groups. That is causal comparative design. Uh, so these are more or less the material presented in block 3. Comparison between causal comparative and correlational designs are given here. Just go through this because I have discussed many things in this period. You will be able to, I guess, you will be able to understand the points written here. So that is the end of block 3. And tomorrow we will continue with block 4 of MPC5, tomorrow and day after tomorrow. That will be the last 2 classes. I am requesting Annapurna not to ask anything else here. Please, you have your own WhatsApp group, I guess. Ask there. Ankita, I am not teaching MPC6 here. What questions do you have? Do you have any question, Ankita? I am only assigned with MPC5. Okay, Mann-Whitney U-test is, yes, Mann-Whitney U-test is included in MPC6. I am not teaching MPC6 here. When there will be MPC6 classes, we will discuss there. If I take or if any other teacher takes. Anupama, Annapurna, that though I don't know. You are from which college? What is your study center? Annapurna? Thank you, Payal. You are from which college, Annapurna? Okay, then ask your Muralidhar classmates. How do I know? Okay, so thank you. I am ending this session here. And in the coming 2 classes, we will discuss block 4.